is that when we have different degrees of polynomials, okay? But first off, domain and range, because it seems to be a weird thing to remember what domain and range stand for. The domain, remember, is all possible values of x. Whereas the range is all possible values of y. Okay. Your domain is restricted by vertical asymptotes. Your range is restricted by horizontal asymptotes. Restricted by whereas the range is restricted by horizontal asymptotes. So it's when y equals something. All right. It's a very, very common thing that you guys tend to forget how you work through domains and ranges. Okay. Remember, your domains are all your possible values of x. Your range is always going to be all your possible values of y. Your domain is restricted by a vertical asymptote, whereas your range will be just restricted by a horizontal asymptote. Remember, think of it this way: when there's a horizontal asymptote, it can't go past it, and it can't come below it. So it's stopped as it's moving up and down. Same thing as you're going left and right. Can't go through that. Can't go through that. So then it gets to this fun stuff.
I think you purposely looked at me and said, oh, whatever.
You're the one. So when it gets to what I handed out to you, this is what I'm going to rewrite it so it makes a little bit more sense to you, because all this sheet is saying is polynomials with greater degree. Okay? What this stuff is saying, all this mumbo jumbo, is that we still have the rational functions where you have polynomial divided by polynomial. It's some poly with a higher degree divided by some other polynomial with some higher degree. Okay? When they're writing it out in terms of how it looks, where it's, am to the x to the m plus am to the x to the m minus 1 and so on and so forth, that just stands for descending order. It's a polynomial written in descending order, guys. Okay. So, example would be something very simple. 2x squared minus 4. That's a polynomial with a higher degree. It's written in descending order. Divided by some other polynomial with a higher degree. X squared minus 6x plus 9. That's another polynomial written in a higher degree in descending order. All right, that's all that means. Now, what happens when this goes through, it doesn't fall into one of these two cases from yesterday. What happens now, in order for us to figure out our asymptotes and things like that, we have to go through a series of checks. Well, the first thing is that your x-intercepts are always the zeros of the numerator. All right? Always. Your x-intercepts are the zeros of the numerator. The vertical asymptotes are always the zeros of the denominator. Just like it was yesterday. What's up? No, vertical asymptote. Yeah, y-intercept could go anywhere. All right, y-intercept is just when x is equal to 0. So here we'd have a y-intercept at -4/9, if you wanted to get fancy. The last part is the horizontal asymptote. The horizontal asymptote is what moves around depending upon degree. The horizontal asymptote can be at one of 3 spots. And that's what they're talking about as far as this checkpoints. These 3 different checkpoints talk about the degrees. Degree of m versus degree of n. It's either m is the degree in the top, n is the degree in the denominator. Okay? So if m is less than n, the degree of the top is smaller than the degree of the bottom. I'll write it like that. Top degree is smaller than bottom degree. Then you have a horizontal asymptote at y equals 0. Okay? That's what they're telling you to do. They're checking degrees. Who wins the battle? Which one has the higher degree, top or bottom? So if the top is a smaller one than the bottom, asymptote at y equals 0. If they're equal, well, what happened yesterday when the degrees were equal? Since these degrees were equal, we looked at the coefficients. Same deal. Exact same thing today. If the degrees are the same, if top degree equals the bottom degree, then the asymptote would be at y equals a over b, or think of it as the coefficients.
As an A over C.
Oh, excuse me, thank you. Leading term coefficient over coefficient. That's where that will wind up at. Exactly the same thing as what we did yesterday. When you had the exact same degrees, we had that y equals whatever the leading term coefficients fraction was. It works for every higher order degree as well. If both of them were cubes, same deal. And then the last one, if the degree of the top is greater than the degree of the bottom, I'll get it. There are no horizontal. Okay. There's no horizontal asymptote at that point.
Okay.
It's really, as you start to get in there, I wouldn't worry so much about that whole end behavior. As you start to plot a couple of them, you'll see, this was the stuff from earlier. Sorry, I didn't grab that. As you start to plot these things, you'll see what they're talking about this end behavior. It's how the tails are walking. One of the things that will happen when the top degree is larger than the bottom, you will have a slant asymptote.
Okay.
All right? You will have a slant asymptote. And I'll show you guys, maybe tomorrow, how to find those. It's actually pretty simple. Okay? It's very, very easy to get a slant asymptote. That way you can see how things are reflected over that asymptote instead of being over the verticals and the horizontals and stuff. Okay? Let's walk through one. Easiest thing to do. Oh, I already wrote that out. Blah, blah, blah. Let's start with this one. Y equals x squared plus 4x minus 5 over x minus 6. Very good. You're halfway done.
No, wasn't even that fun.
Not really, but you.
No, not really.
Degree wise. Yeah.
So You go through your checklist. You go through a list of things to do. First thing you want to do is find the zeros of the numerator, which means you need a factor. So, what times what is negative 5? You add together to get positive 4.
Negative 1 and 4.
Negative 1 and 5. Good. So this is the same as x minus 1, x plus 5. So I have x-intercepts at 1 and negative 5. Do I need to factor my denominator?
No.
No.
No. So what's my 0 from my denominator?
6.
6. So I have a vertical asymptote at
6.
6. And then lastly, m is greater than n, so do we have an asymptote?
No.
No, there's no horizontal. So now you go, oh no, what do I do? Well, we plot. So there's a whole lot of weirdness going on to try to figure out what to do. Well, in a case like this, since the degree is, I'm going to show you the slant right off the bat. I don't think I'm going to show you the slant right away. We'll wait on the slant. But now it's just a matter of really kind of just picking some points. And for right now, since what we're doing is we're just kind of identifying all of our parts, let's use our table to make this a bit easier just to start with.
Those are. It's on me that look. The gap look. Yeah.
You guys remember how to make a fraction bar in the calculator?
Alpha y equals.
Good. It was x squared
Plus 4x minus 5.
over x minus 6.
Yep.
And just for fun, go ahead and look at the graph. You'll see what's going on.
Just for fun. Ooh.
Now, obviously, we haven't seen what's on the other side of the asymptote because of the way that the graph is done. But this starts to give us an idea of what's going on. One of the things that you guys will always be able to tell is that y-intercept. The y-intercept would be when x equals what? 0. So I know my y-intercept in this case is going to be negative 5 over negative 6, otherwise known as 5/6. So it'll be like this. So we looked at our graph, we knew it was doing this, it was coming down, it's going to eventually tail towards the asymptote. We need to see on the other side. So if we hit second graph, we go to our table. We got to get on the other side of the asymptote. And as you see on the other side of the asymptote, it starts way up high, 7 and 72, and it's slowly working its way down. Yeah.
Puts it in a fraction.
There's settings. I believe it's underneath mode. Put it in fraction, I believe, and go from there. So you get the idea of what these things are going to do. Should have had it. Way up here, it's going to do something like this eventually.
Something like that eventually. Oh, that's
But, excuse me. What I wanted you guys to see was the idea of how you walk through just picking the critical stuff. All right. As we get into this more, the problems that you'll be graphing, you'll get numbers that'll be a little bit cleaner. Yeah.
How did you get the
It's always the 0 of the denominator because you cannot divide by 0. So you always say what makes the denominator 0.
No, I meant y-intercept.
Oh, the y-intercept is when x equals 0. So if x equals 0, 0 plus 0 minus 5 over 0 minus 6 is negative 5 over negative 6.
Okay.
And we got 5/6. It's always a nice point people to find. It's one of those pretty easy ones that they don't really ever say you should, but it's always a quick one. Let's walk through another one. Same idea. Let's list out everything and see what gets us. Get all of our asymptotes and zeros and all that junk. Forgot how to factor? What's 3 times 10?
30.
What's 30 add together to get negative 13?
-3.
So you get 3 negative 10. So you get 3x squared minus 10x squared, or minus 10x, excuse me, minus 3x plus 10. So you got to factor it by grouping. So your numerator factors out to be x minus 1 and 3x minus 10. Can you factor the denominator?
Yes,
Can.
Do you have any real zeros with the denominator? No. So there's no real zeros. So do I have a vertical asymptote? No. So our first thing we do, we find our x-intercepts. Our x-intercepts are going to be at 1 and 10/3. Just find the zeros in the numerator. Our vertical asymptote would be at the 0 of the denominator, but remember, these have to be real zeros. Do I have a real zero?
no.
No. So there's no vertical asymptote. And then in this case here,
What zero is on
what's that?
0?
What's 0?
The
Horizontal asymptote.
Horizontal asymptote, because our degrees are the same. If the degrees are the same, what do?
it's the
Leading coefficients.
Oh, I thought, did we look at the second equation?
Oh, this is just the factored form of this. You always look at the degree at the beginning. Okay. I had to factor to get my zeros. That's the only thing I did there. So in this case here, since the degrees at the top and bottom are both x squared, it's just going to be their leading term coefficients. So in this case, it's going to be at y equals
Equal this to 0.
Okay.
But it doesn't have a real.
That's how you identify the critical parts. As you start to get into the graphing, like I said, I'll get you stuff that's a little bit cleaner to pick your own points and whatnot. You look worried. What's wrong? I think you're lying.
Since the coefficients are the same.
You're not like,
We do A over C.
vertical asymptote is not.
So it's.
Can you? Is there a real zero for x squared plus 8? That's fine.
It's A over C.
If it was x squared minus 8, I could have a vertical asymptotes. I could have 2 of them at plus minus square root of 8. But since it's at, it would be a negative. I can't take the. I would have imaginary asymptotes. Imaginary asymptotes, I don't think would work. Just means we won't. Yeah. The y-intercept, we can. It's a very easy point to plot. It's not something that's usually asked you to do, but if you need to find a set of ordered pairs, well, the y-intercept is very easy. In this case, it'd be 10 over 8. You get away from the buffet. 5/4. 10 over 8. Couldn't get away from the buffet.
Oh, no, I get it.
Oh.
Oh. It's still going.
Yeah.
Because if you're at the buffet, you eat a lot. So you over 8. 10 over 8.
Oh, can't that way.
God.
Just stick to math.
Wow. All right. Let's try one different. So let's do this. Let's look at one where we know that we're going to do our domain and range. We're going to graph the whole spiel. Spiel.
Wait, did we finish that?
What's that?
That last one was it done?
Yeah, all I was asking for the critical points. I wasn't graphing it.
Oh.
Like I said,
Okay.
I wanted to get into the stuff where you have to start graphing things where it's going to be a little bit cleaner to pick numbers, okay?
Alright.
A lot of those first ones were I just wanted you guys to identify parts, because now as we start to graph them, they're not going to be as nasty, because I want you guys to be able to graph these things by hand, okay? Excuse me. So I'm going to graph y equals 4 over x squared plus 1. And it's the domain and range. Now, I already put a note in here that we noticed that the degree of the numerator is greater than, or excuse me, is less than the degree of the denominator. Top is less than the bottom. M is less than n. So that means we know that our horizontal asymptote is going to be where? 0. Good. So we just go through the list. Bless you. What is our x-intercept? The x-intercept is the 0 of the numerator. Do we have a 0 for the numerator? So do we have an x-intercept? The vertical asymptote is at the 0 of the denominator. Do we have one?
No.
We don't have a real one. And we know that the horizontal asymptote is at y equals 0.
Oh.
Exactly. So we start. We know we have our horizontals at y equals 0.
Don't have vertical.
Don't have a vertical one. But this is a good example of when it is a good idea to plot your y-intercept. What's your y-intercept?
Is it 4?
It's 4. Y-intercept is 4 because when x is 0, 0 squared plus 1 is 1, and 4 divided by 1 is. So there's one of them. And now we're going to pick a couple points on both sides.
Okay. 1 and negative.
So we'll choose it. We knew it was at 0, 4. Let's try it at 1, 2, negative 1, negative 2. Let's see what happens. So if I use 1, what's 1 squared?
1 to 1.
What's 1 plus 1?
2.
What's 4 divided by 2? So at 1 it is 2. Also then, wouldn't it be 2 at negative 1 as well, because you square? So at 1, we're at 2. Here we're also at positive 2. Let's try it at 2. 2 squared is 4. 4 plus 1 is 5.
Perfect.
So be at 4/5 for both of them. A little bit less than 1. So we know this is happening then. It's approaching the asymptote, but it increases to here, and then it decreases, it comes back out. And that's what it looks like.
What is this?
Nice. Those couple of points on either side there help to see what direction those curves are moving towards. And it's going to drop towards we know the tail is going to approach the asymptotes. And it just increases up to that 4 and just drops itself out. Not so scary, I hope. What do you got? What would domain be here? Ah, careful. Am I ever crossing below y? Am I ever dropping below here? Well, let's start with domain. Is there any restriction on x? No. So my domain is all real. My range, do I ever drop below 0?
No.
So my range is going to be between 0 to 4.
Whoa.
So let's write this out. So it's going to be all y values greater than 0, but less than or equal to 4. Because it equals 4, but it never equals 0. Does that make sense?
Yep.
The domain is all real because there's no restriction. There's no vertical asymptote. There are going to be some graphs where it will be ranges all y values greater than 0, all y values that are less than 0. Sometimes they're jammed in between values. It just depends on the scenario. Okay? And as you plot through them, by playing around with the asymptotes and knowing where all that is.
So the range, the highest number is always gonna be the y-intercept.
No, not necessarily. Not necessarily. I mean, this could have been -4, then it would have been the other way.
Oh.
Okay? It just depends on the problem. Each problem is independent. Echo.
Find the y-intercept.
X is 0.
X is 0.
Okay. Easy point to find. Let's try another one. My head lost track. So we have 3x squared over x squared minus 4. We're going to plot the whole thing again, picking easy numbers to work with and see what happens. Where's our x-intercept? 0. X-intercept is going to be at 0. Vertical asymptotes?
Plus minus 2.
Plus minus 2. Horizontal asymptote? Good. It's at y equals 3. The reason it's at y equals 3 is because you'll notice that the degrees are the same. And just like yesterday, when your degrees are the same, it's the fractional amount of the coefficients. 3 over 1. Yep. Yep. Yeah. So we can have 3 of them if we want.
Wait.
Gosh.
How do you get this?
You could have 3 zeros in the denominator and so on. So we start. We know we have an x-intercept at 0, so we just put a dot to go with it. We have vertical asymptotes at plus and minus 2. Then we have a y horizontal asymptote at 3. So when we break this into, what I want you to see now is that you have different regions. You have one here, you have one in between, and then you have one out here. We have to see what's happening to the values of x within each of those 3 regions. So you're going to have to check 2 points within each of those barriers. Okay? So, I mean, here you're going to see, oh, I'm going to check it at 1 and -1. Here's 2, so I'm going to check it at -3. I'm going to check it at -4. And do the same thing on this side, 3 and +4. Okay? That's what's going to allow you to get your ordered pairs within those 3 separate boundaries. So let's start with 1. What's 3 times 1?
3.
3. What's 1 squared?
1.
What's 1 minus 4? What's 3 divided by -3? -1. So at 1, it's -1. It should be, because you're squaring it. Everybody see that? Since you're squaring the -1, you're going to get the same value because it's a squared term. So at -1, it's also -1. So right off the bat, you know that you can't go up past here, so it's going to do this. Boom. Check it at 3. Three squared is 9. 9 times 3 is
36.
27.
Oh, yeah.
So,
I know, I did this.
so I have 27 up top. Over 9 minus 4 is what? 27 over 5. So that's 5 and change, right?
Yeah.
So it's 5 and 2/5, really. 1, 2, 3, 4, 5. Check it at 4. 16 times 3 is what? 48? And then 16 minus 4 is
12.
12. So at 4, it's 4. So let's do this. Shouldn't it be the exact same ordered pairs on the opposite side, which is negative x's? Okay. So it's doing this on the other side. It takes a little getting used to. It's not a very difficult process to go through. It's just a matter of slowly working yourself through it. And I know that I had another one that I wanted to do. Yes, sir.
Where does the y equals 3 come from? Because we found.
That was the horizontal asymptote.
Oh, okay.
So I know that those tails up on the outer edges,
Oh, all right.
it's not doing, and 1 minute, it's not doing anything. That's for all the baby people. So my domain in this case can be all real numbers except for domain
Oh, shoot.
plus or minus 2. My range is going to be all real numbers except for 3. And just checking.
That's not like right there. Wait, what?
Yeah, domain is everything but plus minus 2. Range is everything except for y equals 3. I wanted to do a couple more of these, so let's just do this.
I don't know, I'm trying to I think it's You said for range it was all real numbers besides x minus 3?
What's that?
What'd you say for range?
Range is all real except for y. Yeah. Yeah, I'm not going to graph these today. We'll graph tomorrow. I want to do a couple more graphs with you guys, but also trying to do domain and range. You should be able to figure out domain and range if you know your asymptotes. Okay? So I do all the important stuff on those, which is just basically going through your checklist. What's your x-intercept? What's your y? What's your vertical asymptote? What's your horizontal asymptote? It's not a bad idea if you want to write down what your y-intercept is, because remember, that's always a nice, easy point to find. You should be able to identify domain and range once you know those restrictions. You might have a bit of an issue on your range if you don't know what side the graph is. So if you want to get rambunctious and just look at the graph, you'll be able to tell, okay? Use your calculator if you want to look at the graph. Some of these are going to really be a pain. They're not as clean to graph as the ones we were just doing. Not to say that that was the cleanest, but, you know. Okay? Give those a shot and see how we go.
Hold on.
We'll do more of the graphing tomorrow.
This will be fun.